Welcome to The Explainer. Today, we're going to crack the case on a tool that, honestly, keeps our whole digital world running smoothly. It's called Postman, and it's the secret weapon for developers, making sure the apps we use every single day don't just fall apart. All right, so let's start this whole thing with a mystery. Every time you check the weather, order some food, or stream a show, your app is crossing these invisible bridges to get information. We call these bridges APIs. But how do we actually know they're safe and sturdy before millions of people start using them? So these connections, these application programming interfaces, or APIs for short, they're basically the messengers of the internet. They're what allow different apps to talk to each other, to request data, and deliver all the services that really make our digital lives possible. I mean, without them, your favorite apps would just be these silent, isolated islands. Okay, so if you're going to inspect these invisible bridges, you need a special kind of toolkit, right? Well, for developers and quality assurance testers, the absolute go-to tool for this job is Postman. You can think of it as the ultimate detective kit for interrogating APIs. Seriously, think of Postman as the magnifying glass, the fingerprint kit, and the interrogation room all rolled into one. At its very core, it's a tool that lets a developer send a really specific message, we call it a request, to an API, and then it lets them meticulously analyze the response that comes back. And this toolkit is super versatile. You can install it right on your computer for offline access, or you can just use the web version from any browser. Now, here's what's really cool. They both sync up perfectly, and that is huge for teams, because it means your investigation can just continue seamlessly, no matter who's working on it or where they are. You know, every good detective knows that organization is absolutely key to solving a complex case. And Postman is built around that very principle, giving you a really clear structure to manage even the most complex API investigations. So first up, you have your workspace. This is your main headquarters, your detective's office. It's where you keep track of all the different cases or API projects you're working on. It's the big top-level container for all your work. And inside that office, each case gets its very own file. In Postman, we call that a collection. A collection holds all the specific requests, all the clues, and all the evidence that's related to one single API. It just keeps everything neat and tidy. Now, let's get to the action. When you're interrogating an API, a detective basically has 4 fundamental moves they can make to get the information they need. These actions are known as HTTP requests, and they are the detective's primary moves. Think of it like this. You're getting existing evidence, you're posting a new lead into the system, you're putting an update on a case file, and you're deleting a false trail. So let's break that down. A GET request? That's just like asking for an existing file from the archives. You're simply retrieving data. A POST request is all about adding a new document to that file, creating new data. Put lets you update an entire existing record. And delete, well, that one's pretty self-explanatory. It removes a record completely. So to put this into action, the detective sends one of these requests to a very specific API endpoint. An endpoint is really just a unique URL that points to a specific function or piece of data. It's kind of like addressing your question to exactly the right person to get exactly the right answer. And here it is, the moment of truth. If the API understands the request and it can fulfill it successfully, it sends back a response. And the most common sign of success? It's this status code, 200 OK. It's basically the API saying, loud and clear, here's what you asked for. You see, this response is just packed with clues. The status code gives you that immediate outcome. Did it work or not? The response body has the actual data you wanted, the evidence. And the headers? They provide all the technical metadata, like what format the data is in. These status codes are grouped into families that tell you exactly what happened. Think of it like a traffic light system. Codes in the 200s are a green light, success. Codes in the 400s mean the problem is on your end, like maybe you sent the request to the wrong address. And codes in the 500s, well, that means the server itself ran into a problem. So after all this technical detective work, why should any of this actually matter to us, the everyday users of these apps? Because every single time a developer gets that 200 OK, it's a small but really vital confirmation that the digital infrastructure we all depend on is solid. It means your banking app can securely get your balance, and your navigation app can reliably find your route. All of this behind-the-scenes testing is what prevents our apps from crashing. It's what protects our data from being mishandled, and ultimately, it ensures those seamless digital experiences we've all come to expect. It's the silent, steady work that makes everything just work. So the next time you tap a button in an app, maybe you'll think about those API detectives who ran thousands of tests, collecting clues and closing cases, all just to make sure that simple little tap works perfectly for you. What invisible connections will you see differently now?